There is a new trending topic in AI communities that is generating a lot of interest and discussions. Around 2 years ago, Neuro-Symbolic AI in the Google search has started a steady increase. And in January 2024, Google's DeepMind team earned a silver medal at the IMO with Alpha Geometry, which is based on a type of Neuro-Symbolic AI. So, what is a Neuro-Symbolic AI? Why, and why now? All started with non-learning computational model in 40s for neural networks, and the first time artificial intelligence term introduced in the famous Dartmouth conference with symbolic AI in 50s. Since that, symbolic and sub-symbolic got own interest back and forth throughout two AI ventures. Now, there is a relatively new hybrid model called Neuro-Symbolic AI, which combines of artificial neural networks and symbolic system. The idea famously related with the book Thinking Fast and Slow by Daniel Kahneman, as describes the cognition as encompassing two components. System 1 is fast, intuitive, unconscious. System 2 is slower, step-by-step, and explicit. So, in another word, System 1 is used for pattern recognition, System 2 handles planning and logical deduction. It's worth to mention approaches like this rooted in Watson behaviorism, which puts the emphasis on the external behavior of a system and its reaction on a given situation rather than the internal state of a system. Obviously, he was talking about the living things, not the computers, but a lot of parallel aspects with the artificial intelligence. This is Henry Cow's Taxonomy of Neuro-Symbolic Architectures. In short, Neuro-Symbolic AI spans the spectrum from the architectures that have neural networks integrate with the symbolic system, but we're going to focus on this type of architecture in this video series. Knowledge graphs provide a structured framework for representing and reasoning over domain-specific information, enabling precise logical interactions within the system. They help ground probabilistic outputs of neural networks, enhancing accuracy and explainability of AI decision-making processes by linking them to a well-defined network of entities and their relationships. Knowledge graphs are a crucial component in neuro-symbolic AI field. In fact, not all models use graph structure, but incorporating the knowledge graphs is also gaining popularity in the field. There is a great survey paper on this topic, and its link is in the description. Neural networks use gradient descent algorithm to basically find the patterns among tokens. They're not built for reasoning engine, and more importantly, they're probabilistic models. In order to use AI in mission-critical jobs, probabilistic structure has a reliability issue, including GPT hallucinations, and each decision should be explainable anyway. At the same time, symbolic AI is limited in learning capabilities, and its handling of uncertainty is problematic in terms of literal semantics. Over the last 2 years, as generative AI gained popularity, substantial work has been done on neural networks to enable reasoning through methods like chain of thought. However, results have not always met the expectations and have a significant GPU cost. Now, hybrid architectures like a neuro-symbolic AI are emerging as a way to reduce computational costs of running an AI system and to solve the complex questions that require advanced reasoning, similar to how DeepMind's Alpha Geometry has performed.